Thanks, and I want to thank Larry too for the intro, the callback on that. And I'll mention that that is a great story. That many years ago, it's true. Elon wanted to get a plant on Mars, and that was kind of a focus of his. And he came to our company, being a life support system that was heavily involved in biosphere, so kind of understood those closed systems. And so in working with them, Elon found out that his biggest challenge wasn't our technology, but it was the launch systems getting there, and they set off on another path. I do want to remind you, Larry, we still have that equipment, and ready to revive it at any point. And I'm actually really excited to be here. I agree with the other participant panelists that it's interesting. I've been in this business for my entire career, a lot of it with NASA, some of the private industry. I remember a time maybe 15 years ago, if you talked about commercial space, there was like a giggle, and that's not the case. We're up here actually doing it and talking about going to some place like Mars as a possibility. And my company was actually started about 18 years ago. People who were at the time still locked into the biosphere, and with a vision of saying they wanted to be, in the cosmos, they wanted to be building the life support systems going into the cosmos. So, I mean, I think at the time they were a little stressed, so it might have been a grand vision, but we're doing it now. My small company is building the life support systems for the private sector and for NASA. And so we're able to do as a small company, we're able to do these kind of entrepreneurial things. So let me go to the next slide. And I have to put up a chart of ISS, because this is about ISS and Mars. And I'm sorry, my other panelists kind of forgot to put that chart in their presentation. And I have to, I think it was in my intro, but I was at one point at NASA headquarters the ISS Commercial Development Manager, so I think that uniquely disqualifies me from claiming any ignorance of any of your questions, unfortunately. But I want to make the point here that ISS is, from my perspective, state-of-the-art. It's taken us a long time to get here. It is our first generation of space station that we can point to that, it's just incredible. But it is, when we talk about going to Mars, it's a whole nother step beyond, especially for life support systems, which is what I want to talk about. So let's go to the next chart. Going from LEO to deep space is a game changer, to borrow the terminology from the chief technology officer, though he hates that term, game changer. Bobby will tell you. And Bobby and I actually started our careers together in the same branch at NASA, designing these types of space vehicles to go to LEO deep space. But it's not just an increase in distance, it's the more issues, as you can imagine. The further you get away, the more you're going to need a reliable system. So let's go to the next chart. Oh, and do note I did put a picture of Mars up here as well. So now, in my first two charts, I'm done with the ISS and Mars pictures. So let's go to the next chart. And we, as an example, we've done, calculations. There are a lot of abort scenarios which can drive your ECLS systems and your failure, your ability to come back. Very critical for deep space missions. Let's go to the next one. And you can tell I have an engineering background because I'm going to, include things like orbital trajectories and stuff like that. Next chart. So ISS does depend on access to Earth. I mean, this isn't anything new for any of you here, and I know Skip's in the audience, and hopefully he'll call me on anything if I've got it wrong, or Sam's maybe. But yeah, we have all these resupply of consumables, delivery, repair and replacement, refurbishment of subsystems. And if you can imagine when you're going out to Mars, these are going to, it's not as easy, and you can't do all these things. So let's go to the next chart. So this is what we have right now, and I had to include a picture of Mark Kelly. He's going to be going up on the next launch. It's complex, and it was not intended to be a deep space exploration prototype, the ECLS and TCS. So let's go to the next chart. And as I just said, it's not demonstrated the reliability, maintainability, long duration in situ resource utilization for prolonged deep space. I mean, these are just facts. These have been documented. I hope this isn't controversial or hurting anybody's feelings. Like I said, I worked on this project for a lot of years, and I do believe it's state of the art. Let's go to the next chart. This is 2 tons of light equipment for water processing. Let's go to the next chart. And this is an example of the extra needs of you need extra water to come up here. This is Carl Walls, another colleague who's now with Orbital, and we need to get the recyclability issue. And I understand we can't give full closure isn't necessarily the goal, but improving it surely can help. So let's go to the next slide. And this is just showing a lot of the ECLS hardware distribution on station right now. And if you look at some of the fine print on there, in 2010, at least 10 of those components were moved, altered, replaced. It gives you a sense of the challenge you have in maintaining and let me remind you, of maintaining the payload, people, on these kind of systems. So let's go to the next chart. This is the oxygen generation system. Again, state-of-the-art and a nice system, but you'll see later in the picture where we're heading with all this. So let's go to the next chart. So I think my bottom line on all this is that right now we have no existence proof for ECLS that we can go to deep space. We do for all the other systems. Structures, you can prove that you've done structures that can withstand those kinds of pressures, loads, etc. And the development needs to begin now for these deep space ECLS. It just doesn't exist. I mean, the levels that you need of testing are on a temporal aspect that we don't have right now. So let's go to the next chart, which will kind of give you a sense of that. For those of you who recognize the picture, that's Biosphere 2, where 2 of my founders helped design, build, and lived in it for 2 years and 20 minutes. They're still bitter over an extra 20 minutes, apparently, since it was the subtext of one of their recent books. And these, previous spaceflight missions, ISS and Biosphere 2, show that the testing the hardware with life, life happens. I can point to a popular fiction, Jurassic Park. It's the same thing. There is biofouling that occurs that we can't even predict, because these, and if you look at Biosphere 2, it had issues, and those were not predictable. And there are other projects like that as well. You certainly don't want to get halfway to Mars and find out you have some fungus growing that's making everybody sick and you don't know why it's there, or no capability to rectify it. So let's go to the next chart.
One of the funny things.
Okay, of course I couldn't help but putting an Apollo 3 picture here, since it had to do with carbon dioxide scrubber. So what we're saying is, no amount of money can accelerate that ECLS testing. What I'm all this is pointing to is saying, we want to go to Mars. We have the perfect test bed right now. We have the ISS. We need to put those life support systems on there now, in that environment, and start testing. Because if you're going to Mars, it's going to take several, this is a lengthy trip, and you need to have factors of safety. You want to test it. If you're going to have a 2-year mission, you got to have I think you want to test this for 2 years, and maybe an extra year. Which means if you start looking at those missions, that means we need to start today, right now. So let's go to the next chart. And quite frankly, this can help reduce the ISS operating costs if we can start showing more elegant, simple systems, because these are going to have to be simpler systems. We can't have the numbers of piece parts that keep breaking down. I mean, in any technology, you're much better getting a simpler system in place that you can maintain. And I understand when we're in this industry, it's just hard enough to get the job done. So your first generation is very complex, but what we got to do is work on getting it simplified. So let's go to the next chart. And here is Paragon's. Of course, I have to plug this because this is what we're really proud of recently. This is our commercial crew transport air revitalization system. This is our CCDEV-1 project with NASA. The box you see them putting into our ECLS testing chamber you know, it's about 3 feet long by 1.5 foot. That is sized to do the oxygen regeneration for the air revitalization for a crew of 7. Compare that to what you've seen now. The other was ISS, a much bigger system, but it's all compacted into that system, that box. We can size it to any of our customers' desires. They can take that box as is. We can modify it. That was developed, and these numbers aren't mistakes. We started with the design, built, completed the build with NASA, going through the review process with us in 10 months for $2 million. Which is just unheard of in this industry to talk about numbers like that. And it has 7 basic functions that you can read in there: carbon dioxide, humidity. This is basically the core of an ECLS system. We've now moved beyond that. We're shaping out the rest of the ECLS system around this, and want to make it available to the commercial partners. We've been in talks with most of them to make sure their requirements get involved early on in this and help shape it. So let's go to the next chart. So bottom line is we need to start testing enabling technologies on ISS now. I think there's a lot of things we can do. My company has a whole list of technologies we'd love to see tested up there. It includes radiators, a technology we've been working on with NASA for some time called solid oxide electrolysis, which we think we might be able to get to 100% recyclability of the oxygen, basically taking the expelled carbon dioxide and making oxygen out. Let's go to the next slide. So this is again, I'm an engineer. So this is a pictorial of our solid oxide electrolysis process. We've been working with NASA on this for a few years. It could even be embedded in a Sabatier reactor, I could go on with several other technologies, but this is one in particular we're excited about, because if you're going to have these long duration missions, again, you want sustainability, you can reduce your consumables. So let's just go to the next slide. I've already talked about this. Let's go to the next one. So I'm going to conclude with saying, ISS is ready and waiting. It is a great platform. I'm excited to go to Mars. I mean, this is, kind of, I know we don't have a mandate to do that yet. I mean, just as an individual, as a member of your community who's been here a long time, I'm excited to get out into deep space. I mean, myself, I got involved with this, like probably most everybody else, because I wanted to go see us explore the stars. I believe it gives us cultural benefits, social benefits, economic benefits. And so anything I can do to help push this forward, and it's been fun, doing this with Paragon, a small entrepreneurial firm. We can push the limits on all of this. And I was glad to be offered a speaking opportunity on this panel with these other luminaries. So thank you, Rich.